my name is Casey Nichols, the project lead for the drum motor test rig, sponsored by Interroll. This video will serve as an overview of the problem presented to the university and the solution that was designed and built by this senior design team. Interroll is a German-based logistics company that manufactures conveyor systems for industrial automation. The project was brought to the university by Interroll's Wilmington plant, which primarily manufactures conveyor rollers, drives, and drum motors. A drum motor is a type of motor that has a fixed shaft and a rotating outer rotor covered with a shell. These motors are used to drive conveyor belts and can often be found in grocery stores and manufacturing plants. The current method of testing is to simply run the motors and gather a few parameters manually. This project was proposed to better the quality assurance of the motors by improving the testing process. To do this, the motor should have a load applied to simulate the real operating conditions. This is a difficult task because the outside shell rotates, making friction the only way to apply a load. Also, the outside shell of the motor should remain unaltered. The main requirements of the system were to be able to apply 100 Newton meters of torque and record the speed, amperage, and voltage. To apply the load without damaging the motor shell, a horizontal conveyor belt torque applicator was designed. When the motor is pressed into the belt wraps around the shell, allowing the motor to rotate the belt. After the belt is rotating, a load is applied by an eddy current dynamometer. To prevent the belt from slipping around the motor, two pneumatic cylinders capable of over 500 pounds together press the motor into the belt to increase the normal force between the motor and the belt. Another requirement was that the system should have the capability of measuring and recording important motor parameters during testing. To do this, we used LabVIEW report generation to create a testing sheet for each motor. Also, with LabVIEW, we created a control system that sets up the two VFDs for each motor specification. To do this, LabVIEW communicates with the VFDs through a Modbus network to change parameters and to start and stop the motors. So this is the current state of the fixture. Right now we have a drum motor mounted to it. The brackets here allow for all types of drum motors produced by Interroll, and it's actuated into the belt with these linear actuators, which soon this will be on here with a belt that will apply the torque through this roller, which is connected to this dynamometer and this torque transducer. At the Senior Design Expo on May 3rd, 2018, the team successfully demonstrated the system. The friction between the belt and the motor was sufficient to turn the mechanism to apply a load. Through LabVIEW, we applied and measured a load of 32 Newton meters, which stalled the motor. The team received recognition for being one of the top 8 teams of the year.